Hello, this is Grinstar, and today I am messing around with YSFX or Reaper's JSFX programming. YSFX is a plugin that can use JSFX Reaper style of programming. So basically, if you have Reaper and you have a bunch of scripts, this can load them into BItwig. And use them, or you can use this style. This video is not necessarily about BItwig per se. You can use this style of programming in Reaper also, but I'm using a BItwig because I like BItwig. Right now, as you can see, the oscilloscope here is changing different wave patterns. It's cycling from a sine wave to a kind of a saw wave to a square wave. And if I turn up the volume, I got two sliders. One's for the pitch and tone, and one is to how fast it changes or cycles. I have a really rudimentary wave sequencer here built. So let's go into code. In the code, it is really simple. I have with the init here, and I am defining three functions. One of the cool things about a programming language is that you can define a user-based function. That means that I can define something and call it several times. And down here, it's being called. And I'll go over what it's actually doing. But right now, this is declaring the sine wave function, and basically all it does is it has a direction. It goes back and forth, and then it uses count, and then it returns the sign of that count. To get your sine wave there. Let me slow this down. So you can see the sine wave right there. Going back down here, I have also a saw wave, and that saw wave definition is that the count goes up from 0 to 1, and then it resets itself and goes all the way down to -1 and goes all the way up to +1, one at a time. So that's the saw wave there. The square wave is it figures out which direction it is, and it's either this one's kind of backwards from everything else. Is that instead of messing with the count or returning the count, we are returning the direction. So it's either +1 or -0, -1, +1, -1, +1, -1, +1, -1, and we have to flip flop back and forth, and that gives us our square wave. So this is the function on how to do a square wave. So down here into the actual part that matters is that every so often the YS or the JSFX plugin will ask for a sample, and you got to return it a number based upon what it's doing at that time. And that number is this counter position here, or count position. Actually, that's not, yeah, so count position. So basically what this does is that for every time it calls sample, it counts up the counter. It counts it up as many times as the change in seconds here. Because what we want to do is that we want to say that if the counter is above 1,000, we want to set direction to 1. If the counter is above 2,000, we set the counter to 2. If the counter is above 3,000, we set the counter back to 0. So it's an endless cycling thing. And then what we say is that if the direction is 0, which if the counter is under 1,000, then the SPL 0 and the SPL 1, which is the sound output, set that to the counter position, which is the sine wave. So first it's going to hit that sine wave, and it's going to do that for 1,000 times, based upon what this slider is saying. That's why the slider works back here, this change in seconds, because basically it counts to whatever the counter is, and you can see what the counter is right here. And you can see it cycling. So basically, this is, if you look down here and look at the counter, when the counter's under 1,000, it's a sine wave. When it's under 2,000, it's the saw, and whenever it's under 3,000, it's the square wave. So that's what these things are doing, and it's calling the sine wave function. It's going to the sine wave, it's executing that function and returning a number. Same thing with the sine wave, something with the square wave. And so what I'm doing is I'm sitting here and I'm changing how the function is returning a number so that we can get a sine wave, we can get in sequence. So through here, I can actually mix and match how the sequences are playing out, depending on what I want to do. So if I want to change it up, I can actually change the coding to be, actually, I want the saw wave first, so I can put in there. So now it goes saw wave, sine wave, if I spelled things correctly. There we go. It'll go saw wave, sine wave, square wave instead of sine wave, saw wave, square wave. So now it's changing up the things a little bit. But it's constantly producing the sound. That's why I have this turned down. Otherwise, it'd be a constant tone. Any rate, I put it in the transgate because it gets boring hearing the same tones over again. Or I just turn it down. Which is perfectly fine because when I was coding this, I wanted to actually see what the oscilloscope says of what our waveforms look like. And also the spectrum. So it's pretty cool that of course you could do this in BItwig Grid. Not a real difference here, but there's something a little more challenging about thinking about how you would put this together. So in my mind, I wanted to see what would happen if I changed the different wave files 1 second after each, or well, literally after a timing after each other, and what that would sound like. Actually, I want to combine them more together to make them more equal at a certain point in time. But right now, it's just dedicated to doing a sine wave, saw wave, square wave, one after each other. So the whole wave file, if we break it down, actually that seems to be. I want to record this. I need to send this to audio. So we'll say no input. I want input from this guy, post. And I think that's not getting anything because I said post and then I turned it down because I have the thing on here. Okay, so recorded now on the second one. Let's go in and look at this and see what kind of things that we're seeing. So we're seeing square waves in here. We're seeing sine waves, and we're seeing saw waves in the recording. As you know, we're seeing this in the oscilloscope, so we're doubling down and seeing it here in the wave editor. So overall, pretty cool stuff. Mind you that these should be about 1,000 steps away. So from here to here should be roughly about 1,000 steps, or 1,000 steps in the JS or YS thing every time it's calling sample. Because going back, we're saying that we move the step counter every 0.001 up to its actual. We're doing it even less than that, probably about 10,000 steps. But we're going up basically 0.0 to whatever the thing is. So this is at 6, so it's 0.06 for every 0.06 for every that's going in. So when we look at our counter should be really quickly looking, but you should see like 0.06, 0.04 because it's adding it, but it's adding it very fast, lightning quick, because it's calling that function a lot, really, really fast. But overall, it's getting what we want in the intended effect. And if we move it down, it starts getting slower because it's taking much longer to get like 0.02 that gets up to that 1,000 scores, so that we can change the type of file. So now it's actually going to be longer going across rather than, the 0.06 would be faster versus the 0.02. But overall, you can see that how that's affecting it. So let me do a slow roll so that you can look at the code that's in here. You can literally copy over this code and put it in your own JSFX, or if you get the YSFX, look in the video of where I compile it. There's a link on there, or should be a link in the description on how to download it. I have it on my Google Drive. A copy of this. That's the VST3 and the clap format, so that you can try it yourself if you have a Windows machine. I think I only have a Windows machine, so I only did it for Windows. So let me slowly roll this code so you can see exactly what needs to happen. Overall, these are comments. They don't actually exist. They're just in there so that if I wanted to go back to what I was doing, which this is based upon, all this code was originally based upon the original video I did with the sine waves a while ago. But overall, it's somewhat pretty simple, and in reality, it should be simple. It's basically all you're doing is a little bit of math to get the numbers to go from -1 to 1 over and over and over again in different ways, and that actually produces the sound. Pretty cool when you think about it. Pretty mind-blowing once you actually realize. Of course, BItwig grid. This should be if you're used to this or used to how synths are made, this should be nothing to you. But for somebody like me that's getting into it and learning how to make it and stuff like that, it's still, even though I know the base concept, it's actually pretty cool to be able to demonstrate this in code, and using math to get it done. And relatively simple math. All we're doing is we're counting, and depending on when we get to a number, we do something with it. And it's in its simplest form. This is how you make the 3 basic waves. For a sine wave, a saw wave, and a square wave. And we're just doing counting, and then all we're doing is we're doing a little bit of conditionals, if statements, and then we're saying if the direction's one way, go the other way, and then we're just tracking which way we're going back and forth. That's it. That's all that's needed for this. And you got sound, the basic building blocks of all music. In digital computers, that is, or analog devices also, I guess, but not acoustic. At least, and yeah, we're talking like solid state and vacuum tubes and stuff like that. Either way. But worked on this yesterday. Wanted to show this off. I thought it was pretty cool. Hopefully somebody liked it, or at least it got somebody motivated to try it out themselves and try to mimic what I'm doing and make it better. The things you can do to make it better is to change the pitch tone out for MIDI. Look at the incoming MIDI message and assign the amount that you go up or down based upon that MIDI key. Because I mean that's all this is basically looking at what MIDI message comes in and then adjusting the amount or the slider to the MIDI message. You can also put some more effects in there. Go grab the code for delay or any of the other effects that Reaper has available, and pop them in there along with this, and so that you can take the number and you can delay that number to be played later on. But overall, thanks for watching. Thanks for listening. And I will catch you again.